All right, this is chapter 1.9, example 1. A display of large juice cans takes the shape of a square-based pyramid with 1 can at the top, 4 cans at the second level, 9 cans at the third level, 16 at the fourth level, so on and so forth. To predict the number of cans for display of X number of levels, determine if this situation represents a linear, quadratic, or cubic function. All right. So they always say linear, quadratic, or cubic, but that's kind of nice. So we don't. Ooh, what did I just do? Quadratic or cubic function. So we don't have to think about the exponential, but we are going to go ahead and write an equation for it. So we just have to think of the differences. We don't have to think about dividing. So 5 minus 1 is 4. 14 minus 5 is 9. 30 minus 14 is 16. 55 minus 30. That's what? 15. No, it's not. It's 25. Helps if Mr. Hunter can add, or subtract in this case. 25. And 91 minus 55, that's what? 60, 70, 80, 90. That's 45 minus 40 minus 4 is 36. Okay? So is it linear? No, those aren't the same. Let's do the next one. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. 36 minus 25 is 11. So it's not quadratic. The second difference is the same. 7 minus 5 is 2. 9 minus 7 is 10. 11 minus 9 is 2. Okay. So the third difference is what's the same. So therefore this is cubic. Okay. Again, first difference, if those are the same, it's linear. If those are the same, it's quadratic. If those are the same, it's cubic. And if we want a fourth difference and those are the same, it would be quartic. Don't worry, we're not going to go over that. Well, that's what it is. So we determined it, but let's go ahead and write a model for it. I'm always going to ask you to go ahead and write a model since we have already covered that. So here we go. A is the third difference divided by 6. So your third difference is 2 divided by 6. Well, that breaks down to 1/2. Okay. For everything else, we don't give you the starting point. Ooh. Remember, your starting point is your x is 0. So we have to back up. Think of it as backing up in layers. I know I can back up 2. So 5 minus 2 gives me 3. 4 minus 3 gives me 1. 1 minus 1 gives me 0. So my starting point is 0. My very first difference is 1. My very first second difference is 3. So those are those pieces of information that I need in order to fill everything out. Really, I need the 2 as well, but we've already used it. So your B value. B value is your first second difference, which is 3, minus your third difference, which is 2, divided by 2. 3 minus 2 is 1, divided by 2 is 1/2. Cool. C. C is your very first, which in this case is 1, minus your A, which is 1/2, minus your B, which is also 1/2, which 1 minus 1/2 is 0, which that's nice, that goes away, makes it easier to write. And last but not least, D is your start. D is your starting point, which when X is 0, Y is also 0. Oops. So your equation for this is y equals 1/2, where is it? 1/2, that's my A value, x cubed, plus 1/2 x squared. That's my B value. And I don't have a C or a D, so I don't need the other two. So what if this said, what would the equation be at the 10th level? How many cans would be in the tower at the 10th level? Would we plug that in for X, or would we plug that in for Y? Alright, well, if you're struggling on that, levels, we'll look at our chart, levels is the X value. So if they want to know the 10th level, we're going to plug that in for X. So Y equals 1/2 of 10 to the third power, plus 1/2 times, put that in parentheses, 10 to the second power. So 10 to the third power is 1,000, divided by 2 is 500. 10 squared is 100, divided by 2 is 50. Scoot over, there we go. So 500 plus 50 will be 550. So in order to make a stack of cans that is 10 levels high, you would need a total of 550 cans to do it. At least using the model that they did. Cool? Alright. Scroll on down and attempt you try it number 1. Pause the video, scroll on down and try you try it number 1. Okay, you try number 1. The number of squares on a checkerboard, including the number of 1 by 1 squares, 2 by 2 squares, 3 by 3 squares, and so on, are shown in the table. So what they mean by that is, you know, they want the individual squares plus the bigger squares that they make, the 3 by 3 squares, and so on and so forth. If the checkerboard is a 1 by 1, there's only 1 square. All right. If there's checkerboard is 2 by 2, well, there's 1, 2, 3, 4, and then the 5th one is this big one out here. So there are, ooh, they say there are 10. There's only 1 square. Now, 2 by 2 board, there are 4 1 by 1s, and 1 4 by 4 for a total of 5 squares. The chart below shows the number of squares contained in 2 checkerboards. That's interesting. So, in one checkerboard of 4 by 4, which we have right here, we counted 1, 2, 3, 4, and then a big one. That's 5. But they did 2 checkerboards, so times 2, that's 10 altogether in 2 checkerboards. All right. In a 1 block checkerboard, there would only be 1, this one right here, but in 2 checkerboards, there'd be 2. So they doubled it. Interesting. Determine whether the relationship is linear, quadratic, or cubic. Well, let's figure it out. They didn't say or neither, so it's probably going to be one of them. But I haven't done this one either yet, so let's figure it out together. So 10 minus 2, let's use the same color. 10 minus 2 is 8. 28 minus 10 is 18. 60 minus 28, that is 22. 110 minus 60, that's 50. 182 minus 110, that's 72. 280 minus 182, that is 98. 408 minus 280, that's 380, that's 128. Okay, so those are your first difference. So it's not linear. You probably already can tell it's not going to be doubled, quadratic, but 18 minus 8 is 10. 22 minus 18 is 4. Did I do that right? Yeah? That doesn't feel right, but whatever. 50 minus 22 is 28. Yep. 72 minus 50 is 22. 98 minus 72. I think I did something wrong in there. 98 minus 72. Let me pause and adjust and see what's going on here. Alright, so I figured that piece out. 60 minus 28 is not 22, it is 32. So that would change this 4 as well. 32 minus 18 is 14. 50 minus 32 is 50 minus 32 is 18. 72 minus 15 is 22. 98 minus 72 is 26. Good, I'm seeing the pattern by now. 128 minus 98. It's amazing what one little issue will do to your problem. And that's 30. So the second difference is not the same, so it's not quadratic. So let's do it again. 14 minus 10 is 4. 18 minus 14 is 4. 22 minus 18 is also 4. 26 minus 22 is 4. And 30 minus 26 is also 4. So the second difference, the third difference is the same. There you go. All right, so this is cubic. The other piece of information that they did not give us is a starting point. So we got to go back and find that starting point. So I'm going to start off by backing up 4. So 10 minus 4 is 6. 8 minus 6 is 2. 2 minus 2 is 0. Think of it as layers. To back up the outside layer, the middle layer, the inside layer, and go all the way down. So that's my starting point. So they gave us the first difference, the second difference, and the third difference. Those are the pieces of information we need. So here we go. A equals the third difference divided by 6, so that's 2/3. B equals the second difference, which is 6, minus the third difference divided by 2. 6 minus 4 is 2, divided by 2 is 1. Okay. C equals the very first difference, minus A, minus B. Which, I'm going to do these out of order. 2 minus 1 is 1. And 1 minus 2/3 is 1/3. It was just easier for me to think of the minus 1 first, and then do the minus 2/3. And last but not least, D. D is your starting point. Which when x is 0, y in this case is also 0. So y equals, where am I at? 2/3 x cubed plus 1x, I'm just going to say x squared, plus 1/3 x. And we don't need the plus 0 because plus 0 doesn't do anything. And there you go. We have determined whether it is linear, quadratic, or cubic, and then we went ahead and wrote an equation for it. Cool. And again, if the question asked, you know, a board of 10, if the side length of the board has 10 squares, what would be the number of squares on 2 checkerboards? What if I said something like this? If the side length was 8, what is the number of squares on 1 checkerboard? You know, I know it doesn't ask this, but remember, this is the total number, over here is the total number of squares on, on 2 checkerboards. It says it contained in 2 checkerboards. Well, if 8 has 408, well then 1 will be half that in 204. I'm not saying that's a question they'll ask, but hey, it's something we could use this for. So if we know how many are in 2, we can just cut it in half, say that's how many is in 1. Or we can multiply it by 2 and see how many there are in 4. Anyways, I'm rambling. That's enough.